Hello children, welcome back to EDUHUNT classes where you can excel your academics. So far we completed the concept regarding the chapter 1, that is acids, bases and salts, and in that we completed Arrhenius theory, the limitations, advantages and modifications regarding the previous video, right? So here based on that particular chapter 1 concept 5, that is based upon the Arrhenius theory, we have some worksheet bits to do, okay? So regarding that, we have your mains model worksheet bits regarding the worksheet number 5. We will solve that, okay? Yes. Are you ready? Oh yes. So moving to next first bit. That is, which of the following is true according to Arrhenius theory? So according to Arrhenius theory, what is true they are asking us. That's it. So read the options given carefully, okay? Now first one, A. Acid is that which increases the concentration of H plus in aqueous solution. Right or wrong? Absolutely right. Yes or no? Do you agree with me? Yeah, I agree. Because why? Acids are those in which increases the concentration of H plus ions in the aqueous solution. Okay? That is the actual definition of a particular acid also. Yeah. Now, base, B. Base is that which increase the concentration of OH minus ion in aqueous solution. That is also right, because why? Base are what? They increase OH minus ions, like acid increasing H plus ions, right? Yes or no? Yeah, true. Now, see, NH3 is a base according to Arrhenius theory. Right or wrong? No. According to Arrhenius theory, NH3 is not having any OH group. So that is considered as a particular base. And this is regarded as a base in modification of Arrhenius theory, but not in the actual Arrhenius theory, okay? This statement is wrong. And all the above is also not right. And the given option is, what is that? They asked us to find out the true options, no? So A and B are agreeing to that particular bit regarding Arrhenius theory, that acid and base, they do have concentration of H plus ions and OH minus ions in the aqueous solution respectively, okay? So here the options A and B are true. Do you agree with me? Oh yes. Okay. Shall we'll move to next question. Okay. Here the statement wise questions are given. Statement A and statement B. We'll read that. Okay. Statement A. According to Arrhenius theory, substance which can neither give H plus nor OH minus ions in aqueous solutions are salts. True? Okay. True. Because H plus means it is an acid, OH minus means it is a base. If they are not between both two, that is a salt. Okay. Salt means what, children? Telugulo? Uppu, right? Very good. And statement B. Arrhenius theory supports the salt nature of K2SO4. Right or wrong? According to me, it is right only. Because why? You know this equation, how it is came? Don't know? I'll let you give you. Wait. Here, let's write KOH when reacted with sulfuric acid, it gives rise to potassium sulfate and water molecule. You know how? How? This I discussed in the concept, no? Arrhenius theory concept. Did you remember? Okay, no? Okay, I'll write names also for you here. KOH is named as potassium hydroxide and H2SO4 is, what is that? Hydrogen sulfate, or also called as which acid? Sulfuric acid. Very good. It liberates, what is this? Potassium sulfate and water molecule respectively. So here in this particular equation, given the option, no, what they gave, K2SO4 is, according to Arrhenius theory, it supports the salt nature of K2SO4, which means it is there, no? Acid plus base, here let again, acid, this is acid, right? Yeah. H2SO4 sulfuric acid, or also called as hydrogen sulfate, is regarded as a acid, and KOH, it is a base. When B's both react, they gives rise to K2SO4 is a salt and H2O is a water. Is it accepting or not? It is supporting salt nature or not? So absolutely K2SO4 is supporting the salt nature according to which theory? Arrhenius theory. This is a different concept also, children. Okay. So regardingly, I say A and B both are true. Before that, let's have a balance equation to this. Just a second. Here K is 2. So I have to write here balancing 2 over here. Okay. 2. And here H2. I have write over there O is 2 again. Okay. Fine. 2. Okay. This is a balance equation. Okay. So regarding that, what is the even equation correctly, children? A is true, B is false? No. A is false, B is true? No. A and B are true? Absolutely C. Yes, C is the right option. Okay. A and B are false or not right? So option is C is true, because why? These both are statements are giving true options, true regarding the statements, regarding okay that. Okay. This is explanation for the statement B, children. Hope you understood. K2SO4 is a potassium sulfate salt. So it is accepting, giving salt nature regarding Arrhenius theory. Okay. Because H plus ions of acid and OH minus ions of base reacts to give a salt and water respectively. Okay, children, regarding this, are you clear? Moving next bit. Should I? Yes. Question number 3. Which of the following are the examples of Arrhenius acids? According to Arrhenius, what are having the acid definitions and regarding me? That only you have to tell me, not all, not modifications. Okay, tell me. It according to Arrhenius acids, it should have hydrogen atom in the particular formula, molecular formula, and after that, what you have given, it should liberate H plus ion in the aqueous solution. Yes or no? See the options. All options are having H atom in that. Yes. Oh, then all are having H and H. So all can be acids. Yes or no? Yes or no? Okay. So HCl, hydrochloric acid, is an acid. H2SO4, sulfuric acid, is an acid. HSO4 minus, what is this? Hydrogen sulfate ion or bisulfite ion is also an acid. And CH3COOH, acetic acid, is also a acid, because why it is having H plus ion, right? Children, how to clarify all this? I'll just write here once again. H plus atom and H ion I'll write here. Okay, yeah. So Arrhenius acids, according to Arrhenius theory, okay, the acids should contain hydrogen atom in it, and it should liberate H plus ion in the aqueous solution. Okay, this is all about that. Okay, so after that, I want to include the names here. HCl is called as hydrogen chloride or hydrochloric, come on children, acid, very good. And H2SO4 is called as what acid? Okay, namely hydrogen sulfate or which acid? Sulfuric acid. Very good. Which acid? Sulfuric acid. Next. This also having H, no? So that's the reason it is included in the particular concept of the Arrhenius theory acids. Okay. Now next, it is HSO4 minus. What is that? Hydrogen sulfate ion or bisulfate ion. This is the name for HSO4 minus. Okay. Now last, what is that? CH3 COOH, that is having the name acetic acid. What is this, children? Acetic acid. These are the names for the given following options A, B, C, D. Okay. So HCl, hydrogen chloride or hydrochloric acid. H2SO4, hydrogen sulfide or sulfuric acid. HSO4 minus, hydrogen sulfate ion or bisulfate ion. CH3COOH, acetic acid. So these are all acids because of they have H plus ions. You know how? Here in HCl, okay. Here in HCl, it gives rise to H plus and Cl minus ions. That's the reason why it is considered as a acid, because liberating H plus ions, right? It is also having H atom, right? Acid, okay. Now, HSO4 minus, it gives rise to H plus ion and HSO4 minus. Okay. What about this? It gives rise to H plus and SO4 minus 2. Okay. What about CH3COOH? CH3COOH in the aqueous solution gives rise to CH3COO minus and H plus ion. You know what is the name for CH3COOH? Acetic acid. Very good. What is this ion named as? Acetate ion, and this is hydrogen ion. You have to know all the names, children. Okay, this is not an easy task for you to remember all the given names. You have to keep on practicing. Okay, you have to remember all those things. Okay, acetate ion. This is hydrogen ion. Because of you, because you'll confused regarding all this, I'm giving you all the names to identify and to remember. Okay, so note all these things and keep on revising them. At one point of time, you can happily read all that with your own. Okay, now, so these are all having H plus ions. So hence we can name all the options A, B, C, D as acids regarding the Arrhenius theory. Clear? So all the options A, B, C, D are all the above regarded as Arrhenius acids. Okay, clear now? Okay, moving to next bit. Question number 4. Which of the following are Arrhenius bases? Because it is previously it is an acid, no? Previously these are all acids. Now it is regarded as base. So let it again for you. Yeah. Okay. Arrhenius bases. According to Arrhenius theory, bases are something, they should contain OH group and they should liberate OH minor ions. What is that? Which ions are those? Hydroxyl ions upon dissociation in the aqueous solution. Okay. So if you see the following options, children, according to Arrhenius theory, should have OH group, right? OH group. Yes. In the following options of NaOH, NH3, CaO and Na2CO3, what according to you is a base? Arrhenius base. See, remember, Arrhenius base, not generally base. Arrhenius base. Come on. Option A is right. Because why? It is having OH minus ion. Because why? Upon differentiating in the aqueous solution, it will dissociate into Na plus and OH minus ion. So it is having OH group in the chemical formula and also giving OH minus ion in the aqueous solution. So it is regarded as Arrhenius base. Whereas B, C, D are also bases, but not according to Arrhenius theory, but according to the modifications of Arrhenius theory. You know how? These three, upon acting with the water molecules, they give particular OH minus ion. So that is the reason we have after how? I'll write it away once again. These three, NH3, CaO and Na2CO3, these three upon addition with water molecule, they will give rise to OH minus ion. Okay. But before it is not having any OH group in the particular formula, chemical formula, and also there is no liberation of OH minus ions in the aqueous solution. But after adding with the water molecule only giving OH minus ion. So after this it is named as a base, so that is named as the modifications of Arrhenius theory regarded as a basis, but previously is not. Okay, they just as Arrhenius basis, not the modification. So I didn't mention regarding that. Okay children, did you understand now? Yes. So here regardingly, if I write the names of the 4, NaOH is named as sodium hydroxide, sodium hydroxide, and what is the name for NH3? NH3 is ammonia, and what is the name for CaO? Very good, calcium oxide, and what is the name for Na2CO3? Sodium carbonate. Very good, sodium carbonate. Okay, so this is the names for the particular chemical formulas children. So but according to Arrhenius basis, there is only representation of OH group. That's the reason I chose only one option A. These 3 are also basis but not regarding to Arrhenius basis. These 3 are regarded as basis after the modification of Arrhenius theory. So then I didn't chose B, C, D. Okay, clear? But these 3 are having basic nature, but Arrhenius failed, no? So in the modification classes, I told you this. Okay? In this particular bit, the option is A, NaOH, sodium hydroxide. Okay? Clear, no? Regarded this, clear, right? Very good. So 4th question option is A, and moving to 5th question. Okay. Which of the following are not considered as acids by Arrhenius theory? Okay, tell me. According to Arrhenius theory, there are some given options in the concept I told you that are not regarded as Arrhenius acids, but those are having acidic nature. You know what are they? You know what are they? You have to read the concept thoroughly so that you can get the concept, children. Oh, some of you are already doing the answers. I am happy for that. Some children are not revising and some are doing. Oh, cool. So what is the name of CO2? Carbon dioxide. Very good. SO2? Sulfur dioxide. Okay. SO3? Sulfur trioxide. HCl? Hydrochloric acid, or also called as hydrogen chloride. Children, some have the doubt regarding sulfur name. I guess some will have the doubt regarding this. Okay, I'll write for you. It is sulfur, S-U-L-P-H-U-R, sulfur. Wait. P-H-U-R or S-U-L-F-A-R. Sorry. F-U-R. Okay. So these two are considered as same. Okay. Sometimes there is indication of pH in the sulfur representation, pH, SUL, PHUR, and in some they'll write F simply. Okay, don't confuse, both are correct. Okay, sulfuric acid or sulfuric, F or pH both are same, don't confuse. Okay. So here it is given that according to Arrhenius theory, what are not considered as Arrhenius acids according to Arrhenius theory? Tell me. Very good. Carbon dioxide. Only carbon dioxide? You didn't find anything in this particular question, children? Very good. Sulfur dioxide also. Sulfur trioxide. What about D? It is an acid regarding Arrhenius acid. Yes. But these are not considered as Arrhenius acids. Because why? Because those don't contain any H atom in the particular molecular formula, and thus it doesn't give any H plus ions. But these upon addition with two molecules of water molecule, two molecules of water molecule, they do liberate, which ion you know? They do liberate liberations of H3O plus ions. You know what is that? Hydronium ion, and in that condition, the concentrated hydronium ion, we say these three are having an acidic nature. These three are also regarded as acids regarding the modifications of Arrhenius theory, okay. But this is directly in the Arrhenius theory concept of acids, but these three are in the modifications. So we have to consider which is not means modifications. A, B and C are right options regarding the fifth question, okay. Carbon dioxide, sulfur dioxide and sulfur trioxide namely. This is directly a Arrhenius acid. This is directly a Arrhenius acid, because why? It is having H in the particular formula, hydrogen atom, okay. Okay, move to next bit, question number 6. Okay, match the following column 1 and column 2 are given, okay. So we have the 6 column names. Column 1 we have 6 formulas and column 2 we have 2, namely strong acids and weak acids. Based upon the strength of acid base, we have to remember this, we have to do that particular bit, children. So tell me, what is HCl? HCl is hydrochloric acid or hydrogen chloride, okay. So hydrochloric acid is a strong base or a weak, strong acid or a weak acid? Definitely it is a strong acid. So P, okay. Next one. Now CH3COOH, what is the name of this? Acetic acid. CH3COOH is acetic acid. This is strong acid or weak acid? It is a weak acid. Very good. Q, that's it. Okay, next. HNO3. What is HNO3? Very good. Nitric acid. Nitric acid is definitely a strong acid, because why? Nitric acid is considered as a king of acids, right? Yes. So it is a strong acid as well. So P. Okay. Nitric acid is a strong acid, king of chemicals, king of acids. So strong acid, absolutely P. Okay. Next is we'll choose blue. Not just, okay. H3BO3 is called as boric acid. Which acid, children? Boric acid. Boric acid is a strong acid or weak acid? It is a weak acid. Very good. Q. Okay. So we can eliminate option C and option D. We'll see. The competition is between A and B. Okay. And now next again it is, we'll go with H2SO4. What is H2SO4? Sulfuric acid or hydrogen sulfate. It is definitely a which acid? Strong or weak? Very good. Strong acid. So P. Okay. The given option is B. Very good. Because why? Here Q is given. We know sulfuric acid is a strong acid. So definitely it is a option B. And the last one, it is HCN. HCN is a hydrogen cyanide. It is a weak acid, children. Weak acid. Okay. So absolutely the options A, C and D are eliminated. And the right option is option B. That is PQ. Okay. Respectively. Okay. Got it? Column 1, column 2 matched correctly? Yes. Very good. Here we go with the next question. Question number 7. That is again match the following. This time we have strong bases and weak bases, children. Here we go. We'll do all the 6 again given. Again elimination process we'll do. Okay. And here NaOH. What is NaOH? Sodium hydroxide. We know sodium hydroxide is definitely a strong base, yes, so P. Okay, so B and D are eliminated. Very good. Now KOH is called as potassium hydroxide. And here potassium hydroxide is weak base or strong base, children? It is also a strong base. Okay, P, no? P and P. Okay, A is also eliminated. Now the correct option is nothing but C. We got it. But we have to choose, we have to check, no? One second, we'll check all that. Okay. Now, next given option, given 3 is barium hydroxide. Barium hydroxide. It is a strong base or weak base? Barium hydroxide. How? How to clarify all that? See, if you see the option, don't just mug up, just tell me how barium hydroxide is a strong acid, strong base. Here I have to tell you what a concept, children. I'll let it here for you. Yeah. The concept behind it is, in the strongness of bases, the strength of bases, and in that condition, we write that the group 1, what is the group 1? In the group of periodic table, group 1 or capital, okay, Roman number 1A, those elements metals which have hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, they are no. So those metal hydroxides are having hydroxide are having very strongness of bases, where they are very strong in strength of bases. What are the, children? Group 1 or 1A. In the periodic table, the group 1 or 1A are very strong metal hydroxides. Okay. Whereas coming to group 2 or else Roman number 2, capital A, this you learn periodic classification, don't worry. Okay. These metal hydroxides, okay, these are also metals, children, alkali earth metals. These metal hydroxides are generally strong, that's it. But comparatively, who is strong? See, we have two groups, group 1 metal hydroxides and group 2 metal hydroxides. Based on that, we have more strengths regarding group 1. Okay, but both group 1 and group 2 are having strong bases, in the sense those metal hydroxides are strong. Okay, but comparatively group 1 are very strong regarding with the group 2. So this barium is there, no? Barium comes under group 2. Okay, barium comes under group 2. I'll write that for you. Wait, children, no need to confuse. I'll write for you. There are some group 1, here it is group 1 or 1A. Those elements, the metals are hydrogen H, lithium Li, sodium Na, potassium K. Clear, no? Did you understand? Okay. Rubidium Rb. Oh no, wait. Hydrogen, lithium, sodium, potassium, rubidium, cesium. Yes, Cs, cesium, and Fr, francium. So these all are regarded with the group 1, whereas these are named as alkali metals. So these metal hydroxides are very strong, and regarded, we have other group, that is group 2 or 2A. Those are having the metals, namely, after this lithium is there, no? That we have tried here. Okay. Beryllium, magnesium Mg, beryllium Be, magnesium Mg, calcium Ca, little bit down, okay, strontium Sr, okay, beryllium, magnesium, calcium, strontium, barium Ba, and radium Ra. So these are having the group 2 names, okay. Fine. So comparatively all these are having strong metal hydroxides, okay. These are named the group 2 children. These are called as alkaline earth metals, okay, alkaline earth metals. So these both containing hydroxides, which means, in the sense I'll write here, just a second, which means LaOH, NaOH, KOH, RbOH, CSOH, FrOH, all these, FrOH is radioactive. So all these are having hydroxides, metal hydroxides are very strong, similarly with that of these three, magnesium hydroxide, calcium hydroxide. Here we have no barium hydroxide in the previous question. So these are also having strong particular bases. So group 1, group 2 are having strong metal hydroxides. Comparatively, group 1 will have more strength regarding with that of group 2 in the metal hydroxide sections. But in the previous thing, children, you go here didn't write OH, you know why? Because H is not a metal, H is a non-metal, okay, H is a non-metal and it is a radioactive element. And because of that, I didn't write few things that you learn in the particular periodic classification topic. And here it is named no barium hydroxide. So in that case, we have to remember barium is a coming with group 2, which is having a strong base, okay. It is a strong metal hydroxide, so strong base. Clear no? P. Okay. Now calcium. Calcium hydroxide also, what is that? Belongs to group 2. It is also strong base. Very good. You are understanding clearly? Okay. Yeah. So group 2 is belonging with calcium, is also P. Okay. Now NH4OH, I'll the name over here for you. Calcium hydroxide. Okay. Now coming with fifth one, that is ammonium hydroxide. What is that? Ammonium hydroxide. This is strong base or weak base, children? Very good. It is a weak base, Q. Okay. Now last, ALOH thrice. This is known as aluminium hydroxide. Aluminium hydroxide. And this aluminium belongs to group 3. Okay, group 3. And this is also a weak base. Okay. Only group 1 and group 2 are mainly regarded as metal hydroxide, very strong, and remaining are having weaknesses, weak bases. Okay. This is a concept regarding the particular bases, the strong bases and weak bases. Okay. So here is that P, 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 Q, Q, P, 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 Q, Q. Option C is matching with that of strong bases and weak base regarding with the column 1 and column 2 respectively. Okay. This is the particular match of following with that 7th bit. Okay. Clear? Now move to next question. Question number 8. Okay. Which of the following statements is or are true? Okay. It may be multi-correct also. Okay. For stronger acids and bases, the values of K and Kb are relatively large. Oh yes, children, did you observe, did you remember the constant Arrhenius theory? In that they said K and Kb values are having more large extent regarding with the strongness of acids. Yes, and bases also. Yes, true, no? Yeah, this is true. And for weaker acids, weaker acids and bases, the values of Ka and Kb are relatively small. This is also true. Okay. K and Kb are ionization constants of acids and bases respectively. Okay. A means for acids, B is for bases. Very good. Small b. bases. Okay. Now, option C. Ka cannot be determined for strong gases like HCl and H2SO4. Right. Children, there is a question, there is exception regarding the HCl, H2SO4 and HNO3 also. Whereas these three are completely dissociating in ordinary dilutions, because of that those are not considered as having strong regarding Ka value is not determined. This also we have in the concept wise only. So the Ka value not determined in the particular strong acid, so it is also a correct option for you. Okay. Now option D. Kb cannot be determined for strong bases like NaOH and KOH, potassium hydroxide and sodium hydroxide. Okay. So these two are also exceptions regarding the bases. Okay. So we have all the 4 correct options. Okay. So remember, in acid section, hydrochloric acid HCl, sulfuric acid H2SO4 and nitric acid HNO3, these 3 are not considered as strong acids because the Ka value is not determined. Okay. And in the bases category, we don't have any Kb value for KOH and NaOH, sodium hydroxide, potassium hydroxide. Because why? Because those two are also not having any Kb value, because the Kb value is not determined, because they all the 5 they completely dissociate in ordinary dilutions. Okay. So that does not exist the particular value. That's the reason they are not considered as the K and Kb values they have. Okay. So this is all about the question number 8, where all the 4 options are absolutely matching with that of Arrhenius theory. Okay. Shall I move next question, children? Question number 9. You got this now? Directly from the concept only. Okay. Yeah. Question number 9. NH3 is not a base according to which theory? Whose theory, children? According to whom? We discussed all these things. According to Bronsted-Lowry theory? No. Lewis theory? No. Arrhenius theory? Yes. Yes. Who is science behind it? Svante Arrhenius. Svante Arrhenius. He is which chemist? He is which chemist? From where? Yeah, Swedish chemist from Sweden. Okay. He is a Swedish chemist. Svante Arrhenius. Okay. According to Arrhenius theory, NH3 is not a base, but it is a basic in nature. If we add water molecule, it gives OH minus ions, and that is in the modifications of Arrhenius theory. Okay. Next question. This is the last question for you, children, in this particular worksheet 5. Okay. Identify the substance which acts as a base according to modified Arrhenius theory. Okay. Identify the substance. Okay. According to modified Arrhenius theory, what is regarded as a base? Tell me now. What is regarded as base, acting as a base according to modified Arrhenius theory? Options are SO3, sulfur trioxide, NH3, ammonia, Cn minus, cyanide ion, and C2H4, that is ethane. Names you want? I'll write, wait. This is sulfur trioxide. Okay. This is ammonia. This is cyanide ion. This is ethane. This is ethane. Okay. So accordingly, what is considered as a base regarding the modified Arrhenius theory? Previous one you told you. What is that? Very good. Ammonia. Option B is right. So these are the 10 best regarding the worksheet 5 of Arrhenius theory. Hope you understood and did the bits, solved the bits completely, and see you in the worksheet 5 year bits. Okay. Thank you.